solve question 3 and question 4, which are most similar to a kinematics projectile motion question that you can get on the exam. So to start, let's read the first question. In soccer, a record was set for kicking a soccer ball at 43 meters per second. This is the velocity, so let's highlight it. If the soccer player kicked the ball from the ground level at an angle of 30 degrees, this is an angle that we will use in the solving, from the horizontal, what height would the ball reach? So we're trying to find y maximum. Assume that air resistance is negligible. Okay, let's get started. First, let's draw a quick and easy free body diagram. Over here, this is 30 degrees, and this is going to be VI equals 43 meters per second from where it's being launched. Next, we're going to find VI, the vector components, VIX and VIY. So in order to calculate these, let's take a quick look at this projectile motion, and I'm going to show how we can do sine and cos from this diagram. So we are going to take this vertex as the point which we bring down here, and this will be Vy. This will be Vx. So from there, we will also take this part as the hypotenuse, and then this part will be also Vy because it's congruent with this one. Next, what we're going to do is we're going to label this using this analogy. So good to look. As you can see over here, the opposite over hypotenuse is here, opposite to the 30 degrees. So that means that for Vy, we are going to do sine, multiplied by sine theta. It's going to be 30. Then Vi multiplied by cos theta over here because this is adjacent to 30 degrees. So Vi multiplied by cos theta. Okay, let's start solving now. So Vi multiplied by cos theta is, in this situation, 43 multiplied by cos 30. Here it is 43 multiplied by sine 30. Let's put that in the calculator. And for Vy, we get 21.5. And for Vix, we get 37.239. And the unit for both of these, to make sure you don't miss any points, is meters per second. So now what we're going to do is we need to find the maximum height. Now from the list of kinematic equations, which I can find that the one for height is very simple and quick. There's two, but the simpler one is this one. Vy squared equals Viy squared, this value, and this value is the starting point over here. So it's like the 0, and Viy squared plus 2a multiplied by delta y. Okay, now let's put the values in. So we know that this place over here is considered 0, and 0 squared is just 0. Viy squared is going to be this value squared, 21.5 squared, plus 2, and since this is a projectile, our acceleration is negative. And then for delta y, let's do a quick explanation of this. So delta y stands for the height. Delta y represents yf minus yi. So final height and initial height. Yi is here while yf is over here, or where specifically where the vertex is yf, right? So when we're calculating this, we're going to look at the starting point and realize that it's 0. So we can't really subtract anything from 0, so we eliminate this and it just becomes yf. Continuing, now this is just simple algebra. We move this one to this side and we get 21.5 whole square, and since we've moved it to the side by subtracting it from the opposite of addition, it's going to be negative, equals 2 multiplied by negative 9.8 multiplied by yf. So we know that this will become negative 19.6 due to a calculator, and yf will be our variable, which we divide by. Let's also simplify this. So negative 21.5 whole square gives us negative 46.25 after squaring 21.5, and we're going to make it equal negative 19.6 and put y final over here, and then divide both sides by this number. Negative 19.6, and then also over here, negative 19.6. Next, we take our calculators and we put this number into the calculator, and we get 23.58, which is approximately 24 meters, equals y final, or y maximum, which is going to be this option, B. Thank you for watching.